Okay, so I'm going to go through each problem in the quiz, just in case if you missed one, if you want to know why. This will be it. Alright, so for these first ones, so each of these is the integral of a constant. 3 is a constant, pi is a constant. And so there's a rule for that. So integral from a to b of a constant is just the constant times b minus a. And that's all we'll use for these, so no need to graph for these. So this is, for this one, just 3 times 12 minus 0. It's 36. For the bottom one, pi times 20 minus negative 10. So that's 30 pi. Okay, for these next ones, they say graph the area associated with each integral on a given interval. Then evaluate the integral. Okay, so first we'll graph this function, 1 plus absolute value of x on the interval from negative 2 to 3. Okay, and I think the way I'll do it is plug in the endpoints into the function. So if you plug in negative 2, you get 3. And if you plug in 3, you get 4. And then the this is absolute value of x shifted up 1. So now the vertex is, instead of being at the origin, it'll be just 1 up. And then so the graph looks like this on that interval. All right, so now we're always trying to find the area between the graph and the x-axis. So for this one, just draw a line, these lines, and then realize we'll just be finding the area of these two trapezoids. You could also split it up into like triangle, triangle, and rectangle. Doesn't matter either way. Okay, so this is the area that we're looking for. Okay, so this side, I'll do this. This is 3. This base, which is a shared base between each of them, is 1. And then, let me do this differently. This shared base here is 1. And then this height, if that's a trapezoid, is 2. And this height is 3 for the other trapezoid. Alright, so we'll just kind of do each one of them and then add them. Okay, so for the one on the left, it'll be the area of the one on the left is 1/2 average, 1/2 times the bases, sum of the bases, times the height. This is 4. The area of the one on the right, 1/2 sum of the bases. Oh, whoops, this other base here is 4. So that'll be 1 plus 4 times 3. And that'll be 3 over 2 times 5, 15 over 2. Alright, and then, okay, so this is 7.5 plus 4. So the total area is 11.5. Okay, just so you know too, you could also just add up all the boxes. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you have half boxes. So these two is 10, 11 and a half. So you don't have to always do stuff that formal way. Okay, next one. Okay, this might be the trickiest one to graph, even though we've done it a bunch. But so this is like, you could even rewrite this to think of it differently, as like negative square root of 4 minus x squared and then plus 2. So you can see this is the bottom half of a circle centered at the origin with radius 2, and then that's just shifted up 2. Okay, so normally the graph would look like this, bottom half of a circle, radius 2, but that gets shifted up 2, so it'll look like this. Okay, and then we need to always find the area between the curve and the x-axis. So it's this area that we're looking at. Okay, and this is kind of similar to the last one. This area. Oh, actually, no, sorry, this isn't similar at all. Never mind. Okay, so the way to do this is you could figure out the area of this half circle and then subtract that from the area of this rectangle. Okay, so you can kind of see the area of that rectangle is 8. So it'll be 8 minus. And then this inside here, you know, if this was a full circle, this would be 4 pi. So that means just the semicircle down here, this is 2 pi. So 8 minus 2 pi would be the area. Okay, so we'll graph these and then find the area after that. Okay, so this one, do you see how that expression can be factored? So this is x plus 3, x minus 3. And then those cancel. And so really we're just finding the integral from 0 to 5 of x minus 3. Okay, this has a hole at -3, but one thing, it doesn't matter because it's not in the interval, and even if it was in the interval, it still wouldn't matter. All right, so from 0 to 5, we'll graph x minus 3. Okay, so if you plug in 0, that's -3. Plug in 5, you get 2. This is the graph. And then really we're finding to the x-axis each of these. And we'll find this area here. Okay, so this area here, that's below the x-axis. Once we find it, that'll end up being negative. And then the area above will be positive, so they'll cancel out in some way. All right. You know, this one I'm just going to count boxes. 1, and then that's 2. So this area here is 2. And then this is 1, 2, 3. Those are 4.5. Okay, but this area is negative since that's below the x-axis. Okay, so this will be -4.5 plus 2. -2.5. Okay, next one. Okay, these are kind of the weirder ones, I guess. Okay, so we'll graph 3x, and the limits are kind of strange. That's okay, we'll still graph this. 3x. Okay, and it's from 2a to 4a. And a is positive. Okay, so for instance, if a was here, or if 2a was here, say that's 2a, then 4a would be like right here, like twice that, I guess. Okay, so let's do that. That's 4a. And so we want to find this, the area from here to here. All right, so this is a trapezoid. This height here. So you plug in 2a into the function and you get 6a because the function is 3x. So this is 6a. And then same idea, plug in 4a, you get 12a. All right, and then the height of this trapezoid, you subtract 4a and 2a, so that's 2a. All right, and then we just do area of a trapezoid, just like if they were numbers. Doesn't matter that there's a's there. So you do 1/2 sum of the bases times the height. Okay, this 1/2 and the 2 cancel. So this is 18a times a, so 18a squared. Okay, next one. This is one of those accumulator functions. Okay, so this answer will be in terms of x. Okay, so we want the area from 3 to something, 3 to x, of 4 minus 3t. Okay, so if you, for the y-intercept, it's going to be 4. And then this will go, this has a slope of -3, like here. Okay, we want the area from 3 to x. So actually, let me go a little farther with this. So from 3 to x, okay, so we'll go from 3, there's 3, and then we'll call this x here, just because so we don't run out of room. So we want all this area and that area there. Okay, so since so if you plug in 3, you get -5. So that is just -5, that distance there. Or we could say 5, it doesn't matter. And then if you plug in x, you get 4 minus 3x. So this here is 4 minus 3x. And then this height is x minus 3. All right. So we can do area of a trapezoid again. So 1/2 -5 plus 4 minus 3x, and then times x minus 3. All right, and you could leave it like that. I'll clean it up a little bit. That, and that's good enough. We don't have to FOIL. That's fine. All right. Oh, that's all for that one. Okay, so next one, express the shaded area as a definite integral. Okay, so just rewriting this as a definite integral. And this will be the integral from -2 to 4 of that function. And we'll put the dx in there. Okay, so this one might be the trickiest. Okay, so for this one, we did a similar one with, I think it was x cubed in one of the homeworks. So if you graph this from 0 to 1, so I'm going to do the same thing I did with that other problem. That's 0 to 1. We'll call that 1. And so this will be like a parabola. Okay, so this area, what this says is that area there is 1/3. Okay, so let's graph this next one. So this is a parabola also. This shifted right 1. The vertex is shifted right 1, or everything shifted right 1, and down 3. Okay, so 1 comma negative 3. It's that. And we want the area from 0 to 2 of that. Okay, so let's say you plug in 2, you get negative 2. Okay. And then plug in 0, you get negative 2. Plug in 2, you get negative 2. Okay, so this is the area that we're looking for. Okay, so, and this was the trickiest part about this. Do you notice that this area here is 1/3? Right, that's the 1/3 that they were, that's the area that gets referenced. So this area here is 1/3, just like that area, same thing, that's 1/3. So do you notice you could just find, and the area that we want to find actually is this area. Oops, I'll make this bigger. We want to find all this area here, right? The area between the curve and the x-axis is what you always want to find. Okay, so think about if this whole area here, this area here is 6, and each of these are 3, or 1/3. So it's really just 6 minus 2/3. And that's 16/3. This next one, super tricky. So we're doing, if you plug in 4, you get 0. I'll plug in those limits. Plug in 4, you get 0. Plug in 5, you get 1. And then this is a square root function. So this will look like this. And then we want to find this area here. Okay, and the square root, this would keep going, but we're only interested in that one part. Okay, so do you notice that this area here is 1/3, which means that this area is 2/3. And you can see, because square root and squares are inverses of each other, so this would be a parabola facing to the right. If you looked at like root x and then negative root x, would just be like x squared, but kind of to the right. And so this is the area that's 1/3 in the original. And then since this area is just 1, then this has to be 2/3. Okay, so determine the value of each definite integral using the graph of f of x below, which consists of a quarter circle. So here's a quarter circle, a semicircle, and then 4 line segments. So first one. So we want just the integral of this function from -2 to 6. Okay, so that means we want to find -2 to 6, this area here. This area down there. Okay, so definitely going to split this up in different ways. I'm going to find maybe that area here, kind of this area here, and I'll break it up this way, I think. Okay, so this is a quarter circle. Okay, we don't want this area, but we'll find this area and use it to subtract. Okay, so that's a circle with, we can see that has a radius of 3. So if it was a full circle, the area would be 9 pi. But if it's, since it's a quarter circle, this area is 9 pi over 4. Okay, so that means that since this whole area for this square would be 9, this is 9 minus 9 pi over 4. So that's this area here. 9 minus 9 pi over 4. Okay, this area we can see here is 6.
I did.
Okay, this area, actually we can split it up. We can kind of do this in different ways. This area is 3. You can see this whole rectangle is 6. That means this triangle is half that. So that's 3 also. And then this quarter circle, this is a quarter circle of radius 2. So the whole area would be 4 pi. But since it's a circle, quarter circle, that's just pi. All right, we just add all this stuff up. So this is 3 plus 3 plus 6, that's 12, plus 9 is 21. And then plus this pi, and then minus 9 pi over 4. Okay, and then that's 21 minus 5 pi over 4. Okay, so next one we want to find from 6 to 22, so kind of the rest. Okay, so we want to find this. Split that up that way. Okay, the nice thing, we already found that. This is 3, and we can see this is 12. Just counting blocks. Each block has an area of 1. Okay, and then this, we want to find this area will all be considered negative. Okay, just counting blocks, 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait, 7, 8. And then this would be, this whole thing would be 6, so this little triangle's 3. So this area is negative 11. And then this last triangle, that area is 3. So we just add all those up. Okay, so that's 3 plus 12 is 15, plus 3 is 18, minus 11 is, what was it, 18 minus 11 is 7, plus 9 is 16, and then minus 9 pi over 4. So 16 minus 9 pi over 4. Okay, and then the last one, they want the from 2 to 22, or negative 2 to 22, and that's just all the area combined. And so if we found from negative 2 to 6, and then from 6 to 22, we could just add these, and that'll get us from negative 2 to 22. So if we add these, add the numbers 21 and 16, it's 37. Minus, and then negative 5 pi over 4 minus 9 pi over 4 is negative 14 pi over 4, which is negative 7 pi over 2, and that's it. Okay, similar one. This is an accumulator function. Okay, the function, there's a bonus. Function consisting of a semicircle and 3 line segments. It should say is defined on the closed interval. Okay. Find the absolute minimum of the accumulator function. Okay, so think about how this works. So this area here for this triangle is 4. The area for this semicircle down here would be, the full circle would be 4 pi. So this whole thing is 2 pi. And it's negative since it's below the x-axis. And then this last triangle, base is 3 and the height is 2. So that area is just going to be 3. Okay, now, so this function, it's all the area from negative 6 to whatever you plug in for x. Right? So if x was, if x was negative 5, this would be all the area from negative 6 to negative 5, f of x dx, right? And that would just be this little area here, right? If x was negative 4, right, that'd be all the area from negative 6 to negative 4. So it'd be this area, right? So a little bit more, right? And so they're wondering, find the absolute minimum for any value of x that you plug in. So each value of x gives you the area from negative 6 to that x value. And if we want the minimum, so first off, if this x up here was negative 6, then the area from negative 6 to negative 6 is 0. So that's 0. And then it keeps growing. As x grows, then the area grows, right? Up until you get to negative 2. Once x gets past negative 2, this function starts accumulating this negative area. So it'll start decreasing. The function starts decreasing. And then once you get past 2, the function will start increasing because it'll be adding area. Okay, so the question is, here it's 0. So the function at 2, when x is, or negative 2, when x is negative, this x is negative 2, that's all the area from negative 6 to negative 2, that's 4. But we can see now the function starts decreasing because you're adding negative area. So that function will decrease, 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 decrease up until here, and then it'll start increasing. So the real question is what's this area? Negative 6 until 2. Okay, and that's the area, this 4 minus 2 pi. Okay, this is some negative number, right? Because this is 4. This is about 4 minus 6.28, 3.14 times 2. So that's negative 2.28, about. Okay, and that's got to be the minimum there. So when x is 2, this area function, this accumulator function, will be the smallest that it is on this interval. And so the x value, minimum value, So it'll occur when x is 2, but the minimum value will be 4 minus 2 pi. And so that's the bonus.